We're going to start 10.4 tonight. We have a few more angle relationships that are forming in our circles by some tangents, some secants, and some chords. So you're definitely going to want to start, memorizing these right away, because remember, on the quiz and the test, you won't get any of these formulas, any of these relationships. So you just have to be able to identify these based on how they look in the pictures. Okay, so here's the first theorem that we're going to talk about today. It says if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of the intercepted arc. So remember back in 10.3 what an intercepted arc is. So hopefully you can identify for angle 1 here, we're talking about the arc AB. That's the intercepted arc because that's the arc that's in between the angle 1. So then if I want to find the measure of angle 1, I'm just going to cut the arc AB in half. And then the same thing goes for angle 2. You're going to look at the intercepted arc of ACB and take whatever that measure is and cut it in half. Okay, so it's a really simple formula, because it's really not even a formula, but you just have to remember for the intercepted arc, you're cutting that in half. Okay, so here's a couple examples. I'll work through this one on the left, and then I want you to work on the one on the right for tomorrow in class. So we have this triangle that's been inscribed in this circle, and then we have one of the degrees being labeled as 60. Okay, so notice where this angle lies. It's on the circle, which means I'm going to trace that and go to its corresponding arc. Well, think back from the activity that we did in 10.3 and on that quiz. This arc is formed by this angle that's been stretched back. But remember, it's not going to be the same number because we took it from the center and we stretched it back. So remember, that's going to be half of the arc. So then the arc here, we'll label that as 120 degrees. Okay, because if I have that arc, that angle pulled back, I know that that's half. So now if I'm finding the arc, I'm going to double it. Okay, so now remember, in a circle it's 360 degrees. So if I have 140 and 120, that gives me 260, which then if I want to find this missing arc, because I'm just going to find all of the arcs in order to find these angles, this missing arc then is going to be the 260 I have taken away from 360, which means the remaining piece of the circle, that remaining arc, is 100. Okay, so now when I go to solve for x and y, those are the numbers I'm going to cut in half. So now x is going to be formed by this chord and tangent, and then its intercepted arc is 120. So now to find x, I'm going to take 120 and just divide it by 2. So then x is equal to 60 degrees. And then same thing for y. It's formed by this chord and this part of the tangent. So then its intercepted arc is that 100. So y is going to be 100 divided by 2. So y is equal to 50. Okay? So hopefully that makes some sense for the chord and the tangent forming those angles, and then just basically taking its intercepted arc and cutting it in half. Okay, so work on the one on the right, and we'll go over the answers first thing in class tomorrow. Okay, next theorem, 10.13. So this one says we have two chords that are going to intersect in the interior of the circle. So you see DF and GE intersecting inside the circle. Now notice they're not diameters. They're not going through the center, but they could. One of them could be a diameter. All right, so then the measure of each angle is half of the sum of the measures of the arc that are intercepted by the angle and its vertical angle, okay? This is very, very wordy, very wordy. But what it comes down to is just looking at half of the sum of some arcs. Okay, that's really what it comes down to. So when I look for angle 1, I'm going to look at angle 1's arc. Okay, so angle 1's arc would be EF. That's what angle 1 is forming, or where angle 1 is coming from. Okay, but then it says that's going to be half of the sum of the arc that angle is coming from, and then its vertical angle. So then angle 1, its vertical angle would be here that I labeled 1. So then its arc is going to be DG. Okay, so if we want to write this out, we're going to say the measure of angle 1 is equal to arc EF plus arc DG divided by 2. Okay, that's all we're going to do. And then if I want to get angle 2, I'm just going to take the measure of angle 1 and I'm going to subtract it from 180 to get 2. But if I was just given, you know, the arcs for angle 2, I could solve it this way. The measure of angle 2 is equal to arc GF plus arc DE divided by 2. Okay, so really all it comes down to is paying attention to those vertical angles and then adding up those arcs and then cutting in half. Okay, it's pretty simple. All right, so here's again 2 more examples. I'll work on the one on the left and then you guys do the one on the right for homework per se. Okay, so if I want to find x, here's how x is formed. So I'm looking at that arc. Its vertical angle would be 40, so I'm going to take 30 plus 40 and divide by 2. Okay, so here I get 70 degrees divided by 2. So when we cut that in half, x would simply be 35 degrees. Okay, so hopefully that's pretty easy. Just pay attention on the example that you're going to do. Look at the arcs that were labeled, and then look at the angle that was labeled. So don't get tripped up on, you know, you're not solving for maybe the angles of the arcs. Maybe you have to subtract from 180. So make sure you pay attention to details, okay? Okay, now this theorem, there's a lot to it, but it's really easy. Okay, so you see in one theorem itself, it has 3 different pictures. Okay, but like I said, it's the same thing over and over again, but you just have to be able to see the 3 different pictures that could occur with this theorem. So this theorem says that if a tangent and a secant, I'll underline these, a tangent and a secant, or 2 tangents, or 2 secants, if any of those intersect outside of the circle, then you look at their intercepted arcs and you're just going to find the difference of those 2 arcs. Okay, so we're still looking at the arcs that are in between our angles. So this first picture on the far left is the tangents and the secants. Okay, so here we have your tangent, excuse me while that pops up. So here we have the tangent, and then with C, B, and E, there's your secant. So those 2 lines are intersecting outside of the circle at C. So now hopefully you can see that the intercepted arc is ADE and AB. Okay, so hopefully you can see that. And then all we're going to do to figure out angle, you're looking at angle C here. Okay, so you're looking, we'll call this 1. We're looking for angle 1, so you're going to say the measure of angle 1 is equal to half the difference of those intercepted arcs. So angle 1 is equal to the measure of ADE, that arc, minus, because you always want to take the bigger from, or the smaller from the bigger, because I don't want a negative number here. So then I'm going to take the measure of arc AB and divide by 2. Okay, so hopefully that makes sense. Take the bigger minus the smaller and divide by 2 because we pulled that angle back. So it's not going to be the same. It's going to be smaller, and in fact, it's half the size. Okay, next one then are the two tangents. So you see these guys right here only hitting the circle once at A and at B. So then all I'm going to do is I'm still going to take the bigger minus the smaller, divide by 2. So the major arc here, and I am doing this in green, so you might not be able to see it perfectly, but the major arc is ADB. So I'm going to put the measure of angle C, and you can put a 1 there if you want, is equal to the measure of ADB, that arc, minus the measure of arc, this little guy right here, AB, and then I'm going to divide by 2, and then I'm done. Okay. So the biggest thing with this theorem is just making sure that you can see that it's either a secant and a tangent, two secants or two tangents, and then identifying what the intercepted arcs are. Okay, so hopefully it's not too hard for you guys to see this. So there's your two secants. So then this one, if I look for angle C, the measure of angle C is going to be equal to measure of, oops, that should be an arc, not a line, arc DE minus the measure of arc AB divided by 2. Okay, so again, this theorem is really wordy. There are 3 pictures, but when it comes down to it, you're doing the exact same thing in all 3 of those pictures. You're finding the intercepted arcs, you're taking the bigger minus the smaller, divided by 2. That's it. Call it a day. Okay, so that you don't have too many questions on that. So again, here's some examples. I'll do the one on the left, you'll do the one on the right, and we'll talk about it tomorrow in class. So I'm looking at this angle X on the outside of the circle, and I notice that, you can see this here, these lines are hitting 2 spots on the circle, so I have 2 secants, which means I'm going to find angle X by taking the larger arc minus the smaller arc and dividing by 2. So when we write all of that out, and I do want to see some of this work, I know it's really easy and you can probably do it in your head, but make sure you write everything out, okay, just so we don't miss any points on the test. So then you get X to be 40 degrees. Okay, and that's all you're doing. Bigger minus the smaller divided by 2. That's what 1014 comes down to. Okay, so go ahead and work on this last one. And then tomorrow we'll put up answers for those 3 examples and then look at the homework. So come with any questions. Let me know what you guys are not fully understanding, and we'll go from there. See you guys tomorrow.